Okay. Hi guys, this is the remote working in dangerous times breakout session. Just to remind you guys, earphones are required to participate in the session. There might be some compatibility issues with Hopin for small number of participants, usually not for when you're trying to listen in, but because we're not having participation in this session. So you all can ask your questions on the chat on the right hand side of your screen. We will draw our questions from there to ask our panelists. We have Dr. Alan Shi, which was a Harvard physicist. Say hi, Alan. That's Alan. And we have Jeremy Webb from SE4. SE4 is a very interesting startup doing robotic software for extraterrestrial and terrestrial purposes. Okay, so for today, I'll start off with the introduction. Then Jeremy Webb will take it from there and he'll do a presentation on SE4 and followed by a panel discussion with Jeremy Webb and Alan Shi and myself. And then we'll finish off with a Q&A from the audience. So a lot, because recently we've been having the COVID situation and recently remote working has started to really take off. But even before COVID-19, we actually noticed that a lot of people have shown an interest in remote working, but there was actually still very slow progress towards this as a goal. So like 74% of employees have mentioned that they would change jobs based on work from home policies. And 90% of employees say that allowing for more flexible work arrangements and schedules will increase morale. But the thing is, we actually didn't really see a very huge uptake of remote working in the workplace. And even among those that are able to work from home, a lot of them were the high wage earners, like Charlie mentioned in the earlier main session if you were there. So the thing is, the lower level, especially the low level service workers, which are deemed as more essential, have been unable to have access to telework. So yes, so this is just a slide that I found. Yeah, so COVID-19 was like the main push for a lot of companies to move towards digital transformation out of more necessity than out of their own discretion, I guess. Yeah, but even then, COVID-19 also could lead to a permanent shift in working patterns because of the change because I know that people work from home and they experience that they really like to work from home. They might actually not want to go back to the office and they might push their companies to start to work from home more often. So as people work from home now but the thing is, we still have a lot of jobs, as I mentioned, that cannot be replaced and cannot be done remotely. Like, for example, our low-wage essential workers, like our food service workers, waiters, waitresses, cashiers. So the thing is, because a lot of these type of jobs need like a human to be there, it's like really hard for you to replace a human's presence there. And because of the nature of the service industry, that you need people in order to be there to do the job. So yeah, so in that sense, if we're actually able to replace all these jobs with remote robotics, that will actually be a quantum leap forward in terms of our remote work and remote robotics agenda. So yeah, but if we're actually able, just imagine if we're actually able to do this, if we're actually able to control such robots to do cashiers, to act as waiters and waitresses at a distance, actually there's nothing really that prevents us from using all this to move into outer space, right? So yeah, this is actually where SE4 comes in, because they actually are developing software in order to enable robots to do such works in an extraterrestrial environment as well as on Earth. So they're able to manipulate. So their software enables us to control the robots with sufficient dexterity through the latency that is encountered. Yeah, and I shall let Jeremy take it from here.
Cool. Thanks for the warm introduction. I think Zhe Ming really touched on two very important issues just there. The first one, people might not want to go back to work. And the second one, not all work can be done remotely, because what can't you do via a remote asset is effectively the core of our business and why we started up. So slide, please. Quick video to introduce us. Is there sound on this video?
Yeah, you can't hear the sound.
I can't hear it. Doesn't matter, I'll just talk. So right here, you're about to see a handsome guy from my office. His name's Nathan. Get into a VR headset, and he's going to be controlling these robots asynchronously. The asynchronous part is important because it's one of the things that allows you to do things with a robot you couldn't previously do. So here's an outside world, a view of what's actually been seen in the camera. And then this is what it looks like for Nathan. Nathan can interact with a digital version, a digital representation, a simulation, if you will, of everything that the camera on the robot side is capturing. So he can do basically extreme Lego at a distance. And the cool thing about this software package, which we call Jack, for Jack of all trades, is that Nathan can continue moving ahead of the robot, even if the robot hasn't actually caught up yet. So Nathan can stack all of those blocks into the shape of, in this case, I think it's a space invader. And once he's got a shape that he likes, he can send that to a robot as a goal state. And then the sister app to Jack, which is on the robot side, that picks up that goal state, and then using some pretty simple computer vision and some pretty simple AI, does all of the motion planning, working out how the robot's going to move and when and how it's going to grasp each object and where that object's going to be or not be after it's been interacted with. And send Nathan an okay if it was able to do the thing, and a oh no, I messed up if it wasn't able to complete the task. And in that second instance, if the robot's unable to complete the task, Nathan can jump in manually again in the simulated mode, but this time with a refreshed worldview, so an updated model of the world that the robot's recaptured after its failure. And he can manually override everything, move each piece into position, and then hit go again and give the robot enough information to somewhat autonomously solve its previous task. Slide, please. So we specialize in remote robotics. Specifically, we were formed in Japan in 2018, and we wanted to control robots at huge distance. And I mean like not 10 kilometers, not 100 meters. I know right now because of COVID, 100 meters seems like a really far away place. But actually, we're more thinking to the moon, to Mars, to Saturn, beyond. And there's a huge problem with this. The speed of light is the speed limit for radio signals. So when I send a radio signal out into the stars, it takes about 3 seconds to get to the moon. It takes about 15 minutes to get to Mars, and it takes a couple of hours to get to Saturn. So with traditional remote control paradigms, the most popular of which is called teleoperation, which I'll touch on in later, that is just not possible because teleoperation is one robot to one person, and they are communicating together in real time to effect some sort of change. We really see our technology, though, being useful here on Earth in mining sectors, underwater, and we're testing a lot of these as in sort of proof of concept pilot projects with big partners here in Japan and globally already. Some of them have been put on hold a little thanks to Corona, but they'll be on track again after all of this settles down. Slide, please. So yeah, I said earlier on our software solution is called Jack, and it's called Jack for Jack of all trades, which is an English expression for somebody who's very, very good at lots of things, but is not an expert in any of them. And this, what I've been describing up until now can sound a little like science fiction, but it's all very real and all very true. You could check out our YouTube and stuff later on if you're interested, or just ask me and I'll send you some links, blah, blah, blah. Slide, please. So there's 3 sort of concepts out of popular science fiction that I think make it very easy to explain what SE4 does. For all of you who've seen the film Avatar, and if you haven't, you probably should, it's getting old now. Avatar is an example of teleoperation. A single pilot interacts with a single asset, and they're in one-to-one communication with each other all the time. Whatever the pilot wants to do, the asset mirrors as close as is possible. You can imagine why this is a bad thing to use for remote robotics right now, because we as human beings have arms and hands and fingers, and we live in a 3-dimensional world. But if we're controlling an asset that has wheels, well, humans don't have wheels. So in a one-to-one relationship, how do I mimic having wheels for a robot to accurately replay what I've done with good fidelity? The second one in the middle, The Martian, the book is much better than the film, so I recommend reading the book. It's by Andy Weir. There's a great section in The Martian where he's Mark Watney, who's the astronaut who's stranded on Mars. He's trying to communicate with Earth. But every time he sends a message, it takes 15 minutes to arrive. And then they have to make a response. And then they send the response back. So he sends his message. Imagine sending an email. And before it even got there, you had to wait half an hour. Minimum. And that's when Mars and Earth are as close to each other as they get. When they're further away, it can be 45 to 47 minutes one direction, which means it's well over an hour and a half before you get a response. So if you wanted to do teleoperation, one pilot to one robotic asset, and you had to wait an hour and a half for every single instruction to even reach the asset before it could happen and before you could get a confirmation back. The idea and the concept of two-way communication crumbles. You just can't use it. The last movie there is Ready Player One, which is also a book. The book is, again, better than the film, in my humble opinion. The reason that's there is because VR and AR specifically are the future of how we humans who live in a three-dimensional space are going to interact with robotic assets who have to interact with a three-dimensional space. And what does that mean? Right now, all of you guys watching me on an iPhone or on a computer screen or something like that, you're seeing a 2D projection of something that's happening in 3 dimensions. And that's a problem if you're trying to share spatial awareness. So if I've got my pen and I want to move it back and forwards like this, the only thing it does on a 2-dimensional screen is change size. But in VR, you can move your head around and get a slightly different perspective. You can map the parallax and infer all of the parameters and measurements of the pen, which means that if you want a robot to interact with something, you can immediately give it the appropriate 3D information to do so. That can be a bit of a complicated idea at first, so if you're having trouble with that, you could just drive the system if you want. Come to Japan once Corona fixes itself up. Slide, please. So there's big problems in the fields of robotics for remotely managing assets. And this is one of the reasons that self-driving cars are only just starting to happen. But before self-driving cars, you didn't have a car service where someone else could drive for you with like a PlayStation control from their house. One of the main reasons for that was the teleop breakdown. So the lack of ability to communicate between the asset and the pilot quickly. As a result of that, you can't do really complex things. So if I wanted to take my pen apart with the Canada arm, which is on the International Space Station, I wouldn't be able to do this as it exists right now, because the 1.5 seconds that they wait to send a message to the arm on the space station is already too long. And if you do something like this yourself, a trivial task like taking apart a pen, you'll take note of the way that everything feels in your hands and the feedback loops of when I'm first pushing this, there's an inflection point at which the mechanism becomes loose, and then I know it's okay to unscrew softly. Or before that inflection point, I need to know that I need to continuously be applying more torque until it flips over that inflection moment. And those things are impossible if you don't have real-time feedback, which is why complex interaction is impossible, which is why teleoperation is a bad way to control robots at a distance. The second approach you could have is the full AI approach. So you could make a robot autonomous by making it smarter. But the trouble is right now, there are many problems with AI, but right now the biggest problems are that there's not enough data. So I don't have enough data with enough varieties of arms and enough varieties of pens to teach a robot how to unscrew the lid from a pen, for example. You could train it, and you could do that. You could get yourself an arm, you could get yourself a bunch of pens, and you could start the robot working on the problem. But the trouble is it would only be able to work and be deployed within a very, very, very narrow range of parameters. So it could only work with pens of a certain size, with arms of a certain size, with pens of certain capabilities, with arms of certain capabilities, etc. And that's why we don't see generalized AI tools deployed in our everyday life today. They're all hyper-specialized. Slide, please. So the SE4 advantages of these against these two things is compared to teleoperation, you could use our system for one person to any number of robots. So one person to 50 robots, one person to 100 robots, 1 million robots, 1 billion robots. It doesn't matter. The second thing you could do is control them over any distance. And the reason is because we have solved the problem of real-time feedback being required to do complex tasks. Not all tasks, but more than you would possibly have imagined before seeing it work. The second thing we have against, as an advantage against pure AI solutions, is that the interface for Jack, which you saw briefly in the video I showed you at the top of this this little presentation, that is an interface which captures everything. So every piece of human intelligence that you use to control or interact with or annotate an environment for the robot is recorded, is labeled, and is available later on for you to train on if you want to. And the advantage of that is that with a longer amount of time, the more repeated times that you as a pilot do a certain task in Jack, the more learning opportunity it has to try and slowly start automating that task for you, or deploying what we would call like a driver assist. And there's an analog for driver assists here in the mechanical world. So if you're driving a car, it's got ABS. If you're driving a car, it has power steering. Cars didn't always have ABS and power steering, but now they do. And as a result of which, your driving experience is better and safer. And Jack offers an unprecedented opportunity to do this because it's like evolution. Every single step of the chain, every single iteration you can build on, and it works, providing that the one before it worked. The next thing Jack offers you that AI doesn't is, I'm sure you've seen a video of like a robot falling over on a banana peel or trying to turn a doorknob that wasn't even there. And the problem with these is that AI systems have a loop which you cannot interrupt. So the AI system perceives something, the AI system says, this is the execution, this is the task that I do when I perceive that thing. And then the outcome is, it can be very, very deterministic from a programming point of view. The AI only knows to do one thing. So it will try and do that one thing, regardless of if it's in the wrong spot, regardless of if the thing it's trying to interact with is missing, or regardless if it's already fallen over. So there's no way to intersect that loop in traditional AI-only systems. But Jack offers you this because it deliberately interrupts itself at multiple stages in instruction so that it can get feedback about whether or not to continue or self-assess whether something meets the state that it was pre-queued up on to perceive. Slide, please. So just to summarize Jack, you can jump into it, you can annotate your environment, and annotating your environment means you share understanding with the robot on its side. You can change things in that annotated environment, and then you can send them to a robot that'll execute them, take a couple of snapshots of its results, and then send them back to you for confirmation. But at every stage, it'll do a micro version of that, always closing in on its own loops, always going through its own loops into the smallest possible piece of those loops to make sure that things are getting executed as you, the pilot, had envisaged and intended. Slide, please. So a couple of places that we're already using Jack and have used Jack. So top left is what it might look like if you were driving it. And then in the very middle, top row, that's what it looks like when you're in Jack inside some BIM data, building information management, and that's when they use lasers to scan the inside of a building. So you jump into Jack, and you're inside of this building, and it's almost like playing a game, except unfortunately you've got to do work. Some of the work that project was involved with is the next image across, which is top right, and that's autonomous drilling. So you jump in to the building information management imported environment in Jack. So it's just like standing inside of a high-rise building. Then you look up at the roof, and then you drop a template on the roof. You as a human decide where it's going to go, and then a robot will come in and drill holes into the roof per your template. Middle on the left, that's us controlling a small excavator, a PC-01 from Komatsu, because this system that we've developed to play with blocks or be used on arms can also be used for digging and dumping things. It can also be used to share a digging and dumping for an excavator and a truck relationship, which we're hoping to test in Australia. We were going to do it this year, but I think we'll have to do it next year. Middle on the right is us doing complicated assembly, which is when we print a whole heap of things that we print parts for a bigger part off of our 3D printers, and then we assemble them together. So you can imagine that sort of thing being used at, miscellaneous sections on the manufacturing row of a car manufacturer or something like that, or any kind of manufacturing, really. The more disparate the parts, the more unusual the parts, the more frequency with which the parts change, make our system stronger every time you add one of those things in. The bottom left is submarines, which is some of the coolest work we've been able to be involved with so far. And we're really aggressively targeting underwater applications because that's somewhere that you already can't send humans. It's already too dangerous to send a human 7 kilometers down to work on a pipe that's carrying liquid natural gas or something like that. So they've already been using submarines that are remote controlled for some time, but they've been remote controlling them from a boat. We're going to help them remote control them from the country. So you could be, off the coast of, in this case, Western Australia, for example, in Perth. You could beam your signal up to a satellite, maybe a constellation like JSAT-1, and then you could beam it down to a boat, and from that boat, it could then go down via cable to the submarine. And the advantage of this is you take someone off a boat, which is a really hazardous and dangerous and difficult work environment, and you allow them to work from the comfort of an armchair, maybe at home. Maybe instead of spending 3 months at a time on a ship 3,000 kilometers offshore, they actually get to spend every night eating dinner with their family because they can phone in their work. Then the next two examples are basically more of the same. So the middle bottom example is an example of how we can use Jack's annotation system to interact with an object that the system has never seen before. So I could show Jack this pen, and in it I could annotate it as just a cylinder, and I could drop the cylinder, superimpose the cylinder over what the camera is seeing, and then it'll snap to it and track it wherever that object moves in a scene. And if it can be snapped to and tracked, and that cylinder provides a 3D information about how a gripper might grab onto something, then we can interact with a previously unknown object, which is cutting edge, state-of-the-art, coolest stuff in the world. Then the bottom right is an example of that PC-01 being taken outside. We did a digging project with this, where we controlled it in the very north of Japan, in Aomori, from our office in Tokyo, which is not super far. It's about 1,000 kilometers. The furthest distance that we've tested the system on thus far is we did a demo of assembling that Space Invader, actually, that you saw in the first video, from Toronto to Tokyo, which is about 13,000-ish kilometers. And for that, we were swallowing a latency delay of about 6 or 7 seconds. Slide, please. So who competes with us? Who else is doing this? The answer is nobody, but we sit somewhat in the middle of a grid that would look something like this. So here in Japan, there's a company that makes, there's two companies that make semi-autonomous, kinda, teleoperation. Well, they're not really autonomous at all, actually. They're just teleoperation, but they make bipeds specifically for the purpose of replacing a person via remote control. But because of the limitations I described on teleoperation technology earlier, that basically means that you need to have the operator and the asset probably within 100 kilometers of each other to be effective if you wanted to do quite a complex task. On the other side of things, pure AI, there's DLR, which is actually it's like the NASA of Germany. And they were trying to make a very intelligent robot system that they could send to space, but they abandoned the program because, quote unquote, the technology and the compute power are not there yet. And then there's Built AI, which is a company which wants to do autonomous digging and nothing to do with robots that have manipulators on them and such. Slide, please. What does the year look like for us in 2020? Well, hopefully this Corona thing settles down soon, but we're looking to do some projects with some really big excavators, like 80 to 100 ton, towards the end of Q3. We're also looking to do some projects with some Japanese robotics manufacturers and some Japanese robot resellers. And during Q4, we're hoping to submit proposals for our first space project. We would like to fly a small arm on a CubeSat and prove out our technology that way. And we're looking either to do that with a partner, which we have a few options for, or to do it through some government grant things through our office that we're starting in Australia. Slide, please. After that, 2021 will come. And again, hopefully the Corona thing's over by then. But we'll do some major projects that we did have scheduled for this year, but they've been moved to next year with some pretty huge industry players, like Fugro is the partner we did the submarine stuff with. Blueprint is a company that does arm manipulators, so they make special grappling and arm devices for deep sea. Mervac is a construction company, and Oz Minerals do mining things. And then in 2021, it says we might go to space, but I'm pretty certain we'll go to space in 2021, but I can't talk a lot about that at this time. If you want to know more, so please, please reach out to me or check out our website, watch videos, and yeah, that's it from me. Thank you for your attention.
Thanks. Thank you so much, Jeremy. Okay, let's see if there's any question. I don't see any questions from the audience, but never mind. Okay, so just curious. I'll direct your questions at both you and Alan. Yeah. So just curious, both of you all think that remote robotics will have like a very scrunched out adoption model, just like the way remote robotics was like suddenly rushed into existence, or not rushed into existence, but like the adoption was like rushed only after a very major event has happened. So is it like maybe only after we move to outer space, then suddenly there will be a huge interest in remote robotics?
I'd be interested to see to hear what you think, Alan. But why haven't people been doing remote robotics up until now?
Oh, this is a tough question, right? Well, personally, if I were to invest in remote robotics, right, I don't want. I want it to be compatible with a bunch of different robots, and I don't want it to go out of date really quickly. Or if the business environment changes such that it's actually not economically favorable to use remote robotics, then I kind of just wasted my investment. Like, for example, if I were to go like full steam onto remote robotics and then COVID-19 just ends like next month, then I might have made the wrong choice. I think that's probably what people are afraid of, like making the jump. But as soon as the economics work out, in the sense that if there's COVID-19 or if there isn't, and it still makes sense, I think adoption will naturally happen. How about yourself, Jeremy?
Well, I mean, there's always things like cost, right? Like robots are not cheap. The robots that you saw in the video there cost $50,000 each without the grippers.
Yeah,
and that's also without a cool piece of VR software which drives them. So, what do I think the major adopters are? The problem is that people don't realize this has been an option, and I think this is perhaps something that's pretty poignant for the moment where we are, because like Corona has forced people who didn't know that working at home was an option to work at home. So they didn't know it was there, but years of work on internet infrastructure and making computers smaller and that sort of thing are making remote work possible for these people right now. If tomorrow we found out that Corona is transmitted via strong wind, and basically none of us can ever leave the house again, then we wouldn't have the technology and the infrastructure in place to move to remote robotics for things on dime like we did. We were able to send everyone home that had internet with a laptop and say keep working for almost all jobs, right? But that couldn't happen if we were told that you can never leave your house again and you have to do everything via a robot proxy. We're not there yet. I would like for the community and the countries and for society to get there. But we're just not yet. Yeah. So yeah, I think we're just not ready yet, and that's the reason it hasn't been more widely adopted. But hopefully, we are at the vanguard of a movement which is just trying to increase the general purpose robotics field, which will put us in a better position for when we want to have things that are less exploratory, more mundane, more mainstream, start converting to these processes. I mean, we stopped sending humans to space a long time ago because it was obvious robots are more resilient and they're going to do it better. Where mining companies have been gradually going through a stage of moving humans off of their mines and moving them into remote control centers for trucks, for bulldozers, for explosives. The final sort of things to not automate, but to replace with a remote system in that industry are excavators, which is what we're looking at specifically because that's the last gap in an otherwise very saturated area of the market. But in the construction area, everything's still done with people. And it needn't be. In fact, I mean, per a question that this Rui lady was asking in the chat just right now, how does SE4's drilling thing, for example, stack up against the real world? And the real world, the person does it by hand. So in our case, we were modeling it on Japan. So a guy who's about the average of 36, 37 years old gets on a scissor lift and then holds a drill up and drills holes in. After the day before, the same person got up with a ruler and then with a pen marked out where all those holes are going to go. And you get centimeters of deviation per floor. But with our system, you were getting about 0.25 millimeter over the entire array. So that's maybe you drill 100 holes in the roof. So you measure every single hole to every single other hole, and then you take the deviations and then do that up. So it's about 0.25 millimeter for using a robot, or it's multiple centimeters for using a human. And what happens if this HVAC system's holes are not drilled properly and drilled in perfect lines? What happens when they go to install the HVAC system? Well, they just leave some of the holes out. They just don't use them, which means every now and then there's a row that's missing a couple of holes. So we long ago gave up calculating by hand in favor of calculators. We've long ago given up writing big documents in favor of Word. We are going to give up a lot more stuff to superior technology. And that shouldn't be a bad thing. We should change our attitude to it, right? Because a robot doing something that's repetitive and boring means that I don't have to do something that's repetitive and boring, which means I've got more time to do things that are creative, or drinking Curiosity Cola.
That's true. I think that no matter what, there's like there's two types of robotics, right? One is automating the boring stuff. The second one is just doing the things that need to be remote because it's just so dangerous. For example, like when they send the lunar rovers and also the Mars rovers, it's because of the risks, right? But then the people who are teleoperating these, also maybe a little bit semi-autonomous, not as much as your systems, but these people, they're still congregating at the like control center in the Houston Space Center, right? They're not like social distancing, but so I think there's a distinction to be made between teleoperation and working from home. Like, I think guys working on the rover, if they're all working from home, that could be possible. But it's like,
it is, yeah. So that's that specific issue of why do people still go to JPL to drive a Mars rover rather than driving it from home. There's a few ones behind that, but predominantly it's a security one. So they have in specific for Curiosity and things like that, they have a proprietary like data packet format. So you could, in theory, send it from your home over backbone to internet infrastructure, but it would have to go to a very powerful ground station somewhere. And these ground stations are usually not connected to the internet, not physically anyway. I mean, internet runs to their buildings, but the line which connects to ground stations and the line which connects all the PCs in it to internet are always air-gapped.
Sounds like a job for a hacker, right?
Well, I mean, you'd have to physically hack the space between the wires is what I'm getting at. There's this diminishing returns on the amount of effort you'd have to go to for that one, I think.
Yeah.
We actually have a question from Jeremy. He asked, can you explain the link or correlation between additional layers of abstraction and enhanced human creativity or productivity? Because I think like maybe SE4's product seems like as a layer of like robotics as itself seems like a layer of abstraction. So SE4 helps to aid this layer of abstraction between the human doing the work, like you mentioned, between you twisting your pen cap and the person, and you're not, and the other person, the person operating it doesn't actually sit there and twist the pen cap. So actually still provides the layer of abstraction. So yeah.
I think humans as a species have always been reimagining and retooling the way that they do their work. Most of us are using laptops right now, but 50 years ago, we wouldn't have been using laptops. And 50 years before that, we wouldn't have really been working at companies. But it's important to draw a distinction between what's a layer of abstraction for our working lives and what's outsourcing. So if I'm building guitars, if I do not chop my own wood, then I'm probably outsourcing that. But if I hire someone to work in my same company who does it and I work with them, then am I outsourcing work or have I added a layer of abstraction to my organization? It's kind of difficult to say, but I think there's a good parallel between the way that workplaces and the nature of human work have been evolving in the same way that we've seen evolution in computer chips. So the very first computers that were made, some of my favorites that powered the moon landing and things like that, the transistors in those were all made by hand. So there were people wire with hand pliers and things like that, wiring up a copper solenoid and wiring up a transistor so that they could have an on-off or a closed gate and whatnot. Excuse me. And then gradually that got smaller and smaller and smaller. Until today, you probably have a team of 1,000 to 2,000 people who design a chip. So there are some people in the chemistry area who work at the PNP doping, which is when they add chemicals to silicon to make an electron imbalance on one side of something, so that when you apply a voltage to them, it either skips across which is when the gate is closed and you get a 1, or you don't apply the voltage and you get a disparity between the two electron layers, and then it doesn't skip across and you get a 0, which is where we get binary from. Is that explanation okay, Alan? You're a physicist.
Oh, you mean for the semiconductors?
Yeah.
Yeah.
Okay, cool. So building on that, you've got these chemist people who work out what the chemistry is going to be. And then you've got a team of people who work out how they're going to stack the transistors. And then you've got a team of people who work out what distance the transistors should be away from things like the ALU, the logic unit, or the other gates. And then on top of them, you've got people who work out how it's going to be managed in terms of its heat and its power. And then you've got people on top of them who write the byte code for it, and then there's people on top of them who write the assembly code for it, and then there's people on top of them who write the driver code for it, and then there's people on top of them who start writing C++ on it. And that's about where the mainstream sort of, you could go and write some C++, and you could get in on that level today if you wanted to. You could Google some stuff, you could write a program, and you could do a hello world program or something like that, and that's the level you'd be at. But you can keep going. So you could not do it in C++, you could do it in something, sorry, you could not do it in C, you could do it in C++, which is a bit easier. Then you could do it in JavaScript, which is a bit easier than that. Or then you could do it in Python, which is a bit easier than that again. Or you could type it out in Word, which is many, many, many levels up the stack of easiness. So there's all these levels of abstraction that have enabled people to become more powerful. So I could get a lot further if I was going to write a book today by opening up Word or something like that than I could if I had to go all the way down that whole stack and start working on the chemistry of how do I build better silicon, or all the way down that stack until the C level, which is the level you could get to today if you wanted to go and do some Googling. Like I said, if I started there and I had to write my program so that I could write my book, it would take me a really long time, and it would waste a lot of my time, and it would probably not put the best parts of me where they're best deployed for the most valuable output. So our whole society is built on levels of abstraction, and I definitely see SE4's software eventually providing another layer of that. I used to have to go down the street and pick up my cola from the vending machine, but now there's a rideshare robot, and I can just put my headset on. I can wait in line until it's ready for me to use, and I can go and tell it to go and get that cola thing. And then I'll hear a knock at my door, and my cola will arrive, and it would have been brought to me by a robot that I piloted myself, and I chose what I wanted and all of that sort of thing. So I know I wasn't duplicitously marketed to, and I wasn't manipulated by some sort of Facebook marketing campaign, blah, blah, blah. I know that every part of the stack was me, and that could create a lot of that could really empower someone who is traditionally disenfranchised, So maybe if I was wheelchair bound, maybe technology like this, a layer of abstraction on our society like this, could help me live and be effective and happier in a way I otherwise wouldn't have been able to. And I think that's why we have these layers of abstraction in our society. We have them because they enable you to do something you otherwise wouldn't have been able to do, or they enabled you to do something quickly thanks to the hard work of others.
So it reduces the work that humans actually have to do, so they free them up for more productive things.
Yeah, well, we've only got a finite amount of time. I mean, myself less than most of you guys from the looks of your beards. What We shouldn't be wasting any time.
Okay, we have like 2 more minutes. I think maybe just wrap up with the last question. What do you all think about the 3 laws of robotics by Isaac Asimov? And would there be any concerns in regards to remote robotics? Oh, does SE4 actually follow the 3 laws of robotics?
So let me see if I remember what they are. You've got to protect humans, and then you've got to
Protect yourself. Then,
protect yourself, and what's the other one?
yeah, I forgot already.
I mean, I remember in the book that the the solution that the machine comes up with is to stop people from going outside because they'll hurt themselves. So maybe that's maybe they're trying to say that robots did correct.
The second law is that it must obey the orders given by a human being. Well,
okay. Well, I mean, I think the second law is silly because humans don't always know what's best, and anyone who disagrees with that should try parenting sometime. Because if I let my daughter, who's 1.5 years old, if I let her have her way, she'd probably eat sweets all the time and stick knives and forks into power outlets, right? But and that runs the whole way up the chain. You know, I think we've got a lot of people who are in politics these days who are probably making decisions that they shouldn't have the power to give. So I think the second law is probably not a good idea. But robots not hurting people and robots not hurting other robots, I think they're great. That's a great idea. If for no other reason that the robots shouldn't damage themselves or other robots because they're really expensive to fix. And if you go to space, you couldn't fix them, even if you wanted to.
Could you send a repair robot?
Well, you could, but so right now there's going to be a bunch of missions that leave for Mars this year because every 2 years Mars is very close. No SE4 robots can't hurt people. They've got a vision system which looks for humans and stops operation if it's unsafe. So you can only go to Mars every 2 years, but even right now it takes about 18 months, right? So it gets close to Earth every 2 years and it takes about 18 months to get there, which is why this year a bunch of missions will be sent. But if something happens in the time that you're further away from Mars, it's actually often better to wait and not go until the next window arrives because there's that much of a distance. So if you go to deep space, if you go to Saturn, then it's like 11 or 12 years to get there. And your motivation for doing whatever it was you were doing might dwindle in that time. What if an assassin wants to use SE4? That's a good question. I mean, right now, you'd have to have a pretty stupid person to be killed by one of our robots right now. That changes a lot when we start using bigger stuff. Like I said earlier on this year, we're going to move to some 80-ton, 100-ton stuff. And that's really, really, really dangerous because just by moving, they could kill you, right? But safety always has to be paramount. Just make sure that you're deploying a safety system that's appropriate and capable for the asset that you're using. Rocket Lab versus SpaceX. SpaceX.
Rocket Lab.
Two contradicting views. And then, okay, I think time's up for us. So we need to get them to the next session. I need to put the correct slide.
Thank you, everybody, for watching.
Thank you so much, Jeremy and Alan.